Okay, Calc Part 2. Properties of continuity. Now that we've established a firm definition, let's go ahead and look at properties. So what can we do with continuous functions? If we have b that's a real number and f and g are functions that are continuous at point C, these are also continuous at point C. So these will follow the leader here. So the first one is b times f. So notice I took the function and I multiplied it by a constant. And if we started with f continuous, which we stated we did, and multiply it by a constant, it is also continuous. If we add two continuous functions or subtract two continuous functions, we get a continuous function. If we multiply two continuous functions, we get a continuous function. And if we divide two continuous functions, we get a continuous function. However, we recognize that the denominator cannot equal 0. So that adds a lot to what we know. Our old friends come out to play, and we can establish with rigor that they are, sorry, let me tighten that up a bit. All right. We can establish with rigor that these are continuous. Polynomials like 3x squared, y equals 3x squared plus 2x plus 1. So we can establish there is our the x squared is continuous. So when we put a 3 in front of x squared, it uses principal 1. So that's continuous. So if we add continuous functions, we get a continuous function. So all our polynomials are going to be continuous, and they're always smooth curves. They're up-ups, down-downs, up-downs, all those friends of ours, they're all continuous. A rational function is a function that has a polynomial in the noon and a polynomial in the denom. So those are also, given that these are continuous at a certain point, this rational function will also be continuous at a given point. Radical functions that have square roots in them, so y equals the square root, or even let's say the cube root of x plus 5. That kind of function is a continuous function, and all our trig functions, sine x, cosine x, etc., are, if they're continuous at a given point, if at x, then sine x is as well. So we will be asked to take these ideas and use them in our questions when we come to this work. So hopefully this will give you the foundation and the basic understandings to go ahead and do that successfully. Till then, over and out. Oh, one more thing, don't leave me. Did you leave me? Come back. I forgot. Assignment. I was going to take what we talked about here and go ahead and give you 3 questions to write the answer in your comp book. And when we come together, we'll talk about them. We have one more principle before that. One more principle. If g is continuous, once I start with g, you know what's coming, because usually I start with f. So if g is continuous at a point C, and the function f is continuous at g of c, so I took the point of interest and threw it into the g function, something came out, and then f of that is continuous. So we have basically the fact that if you have two continuous functions, their composite function is also continuous. All right, that's all the basic rigor and definitions. So let's see if you can pull some of that together, and you can look on your calculator or whatever resource you have to answer this question. And what intervals are these functions continuous? So I want you to look at the tangent of x and see if you can find where you think it is continuous. And this is a piece, in pieces, a piecewise. So it's called g of x, and g of x equals sine of 1 over x. So you've seen that earlier this year. You can go ahead and throw it into your calculator. It's one of those badly behaving functions. So when x isn't 0, it does this. When x is 0, it does this. So therefore it is a function. But is it a continuous function? All right, that'll stretch you. So see what your thoughts are on that and why you pick the answer you do. And I don't know if you remember from last year, to try this one, x sine of 1 over x is what the function equals when x doesn't equal 0, and this is what it equals when it does equal 0. So, see if you can come up with some intervals of continuity for these three functions. Now it's time to say goodbye.